Today you have a fairly quick video on density. So we're going to talk about what density is, how to change it, and then you'll be ready for your lab tomorrow. So density is mass per unit volume. Easy way to think of it is how closely packed the molecules are together. Okay? So if you see the picture down here, this object has molecules that are more closely packed than this one. This object is more dense. In simple terms, if something feels heavy for its size, it's dense. If it feels light for its size, it's not very dense. Again, it's kind of an easy way to judge. Pick something up, ooh, heavier than I expected. Well, that's pretty dense. Those molecules are closely packed together. If it feels light, they're not closely packed. We often use density to determine if something will float or sink. And we'll talk about that coming up. To calculate density, it's pretty simple. Just divide mass by volume. Okay, so density is mass divided by volume. Okay, 1 gram of water has a volume of 1 centimeter cubed. So the density of water is 1 gram per centimeters cubed. Okay, again, if you don't know how to do that, density equals mass over volume. So we had 1 gram divided by 1 centimeter cubed, and we get 1 gram per centimeter cubed. Okay, so the density of water is 1 gram per centimeter cubed. Okay, make sure you remember this. We're going to be using this a lot because, again, lots of times we use density to determine if it's something is going to sink or float in water. Okay. The people that made the metric system did this on purpose. Okay, they made water 1 to make it easy. A little more conversion here. 1 centimeter cubed is the same as 1 milliliter. So you can also write water's density as 1 gram per milliliter. Okay, you can write it either way, 1 gram per centimeter cubed, sorry I forgot that, or 1 gram per milliliter. Okay, let's start with another example. A coin has a mass of 2 grams and a volume of 3 milliliters. What's the density? Okay, so we're going to do density equals mass divided by volume. So density equals the mass was 2. The volume was 3 milliliters. Okay, so that'd be, with rounding to significant digits, 0.7 grams per milliliter. Okay. Will that coin float in water? Yes. Okay, because it's less than 1. And you see in the pictures here, okay, it's a Chinese coin. It's made out of aluminum, I think. And it's very, it's not very dense, and it actually floats in water. Most of U.S. coins obviously don't. They're more dense than water. These coins are less dense. Imagine a wishing well full of them. Maybe just cover the surface. So will it float in water? Yes, because it's less dense than 1. Why doesn't the coin float in the air? Okay, so I toss the coin up, and it falls down. Okay? It doesn't float in the air because the coin is more dense than the air. Okay, so it's less dense than water, so it floats in water, but more dense than air. This is a kind of a neat picture here. You see a billiard ball, and it's floating. Do you think this is water? No, it's not water. This is mercury. Okay, mercury is a liquid metal, and you can see it's really dense. That the billiard ball isn't just floating a little bit, it's floating a ton. Only a tiny bit of the billiard ball is beneath the mercury surface. Mercury is very, very, very dense liquid, so it pushes up, okay, with a lot of buoyant force, which is what we're going to talk about in the next lesson. Okay. Again, think about density as how closely packed together the molecules are. So the mass of a metal bar is 60 grams. The volume of the metal bar is 40 milliliters. What's the density of the bar? Okay, so density again equals mass over volume. So density equals 60 divided by 40. Okay, we do that, and we get, what is it, 1.5, which would round to 2 grams per milliliter. Okay. Will that metal bar float in water? No. Why? because its density is greater than water. Okay, it's greater than 1. Okay, what if I cut this bar exactly in half? What will the density of each half be? Okay, will it be 1? Okay. What if I cut the bar in quarters? Will then each of those 4 pieces be a half a milliliter? Okay, so if I had my big bar and it was 2 grams per milliliter, okay, what if I cut it into 4 pieces? Will each of those be a half? Okay, if they were a half, wouldn't they float in water? Okay, that wouldn't make any sense. Okay, just because you take a smaller piece of the metal, they're still going to sink. Okay, it's still going to be the same 2 grams per milliliter because we didn't do anything with the molecules. We didn't change the molecules, we just cut the bar into little pieces. An easy way to do that, okay, let's say if I cut it exactly in half, then the mass of half of it would be 30, the volume of half of it would be 20, and we still get 1.5, which rounds to 2 grams per milliliter. Okay, it's the same, okay, because I didn't do anything to the molecules. Think about a big piece of wood. Okay, let's say if I have a piece of wood and the wood floats in water. Okay, so the density, you know, is less than 1. Let's say the density is 0.5. Okay, what if I had a piece of wood 6 times bigger than it? Okay, so now I have a piece of wood 6 times bigger than it. What's the density of that piece? It's still going to be 0.5. Okay, I didn't change the molecule spacing. Okay, you don't say, oh, 6 times 0.5, that's 3, and now all of a sudden my wood sinks. No, it doesn't work like that. We're talking about the molecule spacing, and by getting a little or bigger piece, we're not changing that molecule spacing. Okay, well then how does a ship float then if it's made of steel? Okay, when we talk about changing the density, we need to talk about changing the overall density. So we can talk about things like ships floating. Okay, so again, we're talking about overall density. We're not talking about that molecule change. We're changing the overall density. And to change the overall density, we need to change one of 3 things. We can change the shape of the object, the mass of the object, or the volume of the object. And again, I put this here just so you remember it. We're not changing the space of the molecules. We're just changing the mass-volume ratio. Okay, we're not messing with the molecules. For example, I could hollow out a log to make a canoe. Okay, if I take my log and I hollow it out, I dropped the mass, but kept the same volume. Okay, so again, density is mass over volume. If I have less mass, but the same volume, I'm going to get a smaller density, and my boat can float. Okay? What if a person gets in the boat? Then it's going to drop lower in the water because I added more mass to it. But hopefully it's still displaced enough water that it will float. Okay, second example, I can reshape a solid block of steel into a boat shape. Okay, if I take a solid block of steel and I make it into a shape like a boat, I've kept the same mass of steel, but it's a bigger volume. Think of it like I've enclosed, a bunch of air. It's a bigger volume, but the same mass, so now it can float. It displaces enough water to make it float. Some other examples. A lot of fish have a swim bladder inside them. Okay, so they have a bladder kind of like this picture shows, and they can fill that bladder with gas. Okay. How does that change the volume and density of a fish? Okay, so let's say the fish pulls air or gas into that swim bladder. It's going to make him slightly bigger, so he's going to expand slightly bigger, so slightly bigger volume, but same mass, and the fish will rise to the surface. What if you're fishing and you drop your worm on the hook into the water, and you see all these little bubbles come up? Well, that means the fish has gotten scared, and he squeezed the gas out of his swim bladder, so the bubbles came out. Okay. because he squeezed it out, he's now a smaller volume, but the same mass, so the fish is diving down away from your hook. Boats are kind of similar, but they're not increasing the volume of the boat. They are increasing the mass or decreasing the mass. Okay, these are called ballast tanks. So you might have walked along a pier and you saw water gushing out of the side of a boat and you got worried or something. No, it was emptying its ballast tanks. Okay, so they have big empty tanks that they can fill with water. And that can make them float lower in the water if they want. Okay, or they can jettison all the water out of their ballast tanks and then they'll float higher in the water. Okay? Why would they want to float higher in the water? Well, maybe it's really calm seas and they want to be really high in the water so there's not as much friction and they save gas. Or maybe they have a really heavy load of cars or something that they're putting on the boat. So they need to get rid of all that excess weight because the cars are going to push the ship down. Why might they want to float lower? Well, maybe there's a storm coming and they want to get really low so their center of gravity is better. So they're going to fill their tanks with water and get really low so they won't tip over. What if they're coming to shore and the water's not very deep? Well, then they're going to jettison all the water out of their tanks so that the boat will float a little bit higher. Okay. So again, this is changing overall density. Okay, again, changing overall density by changing volume or mass. Again, we're not changing the density of those molecules themselves. We're not changing. We're just changing the object's overall density. Okay. That's it. We're going to do buoyant force on the next one. So remember, density is mass divided by volume. Okay, think of it as how closely packed the molecules are together. Water has a density of 1 gram per milliliter. So if something is less dense than 1, it'll float. More dense, it'll sink. Okay, and we can change the overall density of an object by changing the mass-volume ratio. Okay, even though we're not changing the molecules themselves.